Okay, we are live, I guess. Let me check. I think we are live. Mm-hmm. Or no? Okay, I cannot see it, at least from a different device. Yeah, it's live. It's live. Great, nice. So we are live. Jai Jai Shri Ram, and yeah, what's the plan? Mm, I need to work on some rs-stl things. Hmm. So yeah, I have implemented rotate, I have implemented reverse, I have not implemented sort. Right. Now I think it's time to look into sorting algorithms, and before going to sorting algorithms, I need to do this uh, partitioning algorithm, I guess. But before that, let's see if there are more things I'm leaving around, right? So I guess Swift collection should be the thing. So Swift collection protocol documentation. I don't know if the documentation is the Apple developer documentation only or something else, but yeah. So let's see what are the algorithms. Pop first, remove first. Uh, what is this remove first? Uh, remove the first elements and return the. Can we have that? What? Remove and returns the first element of the collection. Wait, is it even possible? How is it implemented? What? How is it implemented? Wait a minute. I don't think it's possible, right? Until unless you have some data structures like linked list or something, it's totally dependent on data structures or like this capability of if it is remove first table or pop first table. Wow, I will have to see this. Swift stud lib, and I wanna see if there is this remove first thing. I don't think it's possible. Hmm. Let me search remove. Wow, what I'm writing. Remove first. Okay. Oh, nice. Where subsequence is self. That makes sense. That if the subsequence is self, then we can have pop first, remove first, and all of it. Pop first, drop first, pop first with position. Hmm. I like this concept. I really like this concept. Currently, I have implemented this thing for slices only. And usually this property is for slices. That's so nice. I think they wanted to implement it on slices and hmm, here is my thing. I really believe there is a middle ground. Like, okay, I have implemented for slices, they have implemented for some things where subsequences self. But here is what I believe. I believe that there is a thing called streams and there is a thing called collection. So stream is the single pass ranges and collection is the multi-pass ranges. There exist some middle ground where we have pop festival range and all those things, and these collections follow these kind of collections follow pop festival range, right? So yeah, this is something we have to realize, like what is pop festival and all those things in going future when we would be working over a high listed live. I would see where can I take it. Anyways, hmm, okay. So currently I'm ignoring pop first because that is something uh, is there in our slices. Let's go start index, end index, indices. I had a discussion with Dave on this one, and the discussion with Dave was for random access collection it's fine, but for language like high-low and Rust, indices on normal collections is really hard to have. So yeah, again I am ignoring this one, and that is why we are discussing like positionless design, right? Now index, form index, these are the axioms for us, so it's fine. Make iterator, I am that is iter method for us. Split, split is nice. So what does split returns? It returns array of subsequences, array of slices. Hmm. So what do we want? Do we want array of slices, or we want iterator of slice? That is a question. Do we want iterator of slice or do we want array of slice? We have to think about it. So let's have it in to do now. rs-stl. Hmm. Okay. So one thing is split algorithm, and right, and the thoughts are if a split algorithm should return array of slices or it should return iterator of slices, right? So that's a question. And we have three kind of split algorithm, that is fine. What is this? Disjoint, contiguous, discontiguous slice. I'm not sure what is that. Associated type, all of it's fine. Iterator, we have three kinds of iterator, to be honest. Like, I have to see, I am seeing that there are multiple kind of iterators we have, right? And that should be the case with high-low also. So we have to think about it, like, what is a mutable iterator, what is that iterator, what is this iterator. Hmm. Anyways, count, uh, first is emptied, all of it's there. Contains method returns a boolean value indicating the this, okay, indicating whether the collection contains given sequence. I think this is a good one. I think implementation of distance is quite simple. Like, implementation of distance for us is literally creating a slice and returning a count. I want to see this thing, if they have provided a distance implementation. Nice. I think they have not provided it. That is fine. Okay, this is how it is provided. I thought they would create slice in the return dot count. Okay, this is the way rs-stl works. So nice. That is fine. There are some things I will have to credit myself that I did good in rs-stl, and that was a really new kind of API design things I was seeing. Drop, I think I have done the first index thing. Uh, the first range thing is fine, returns the range of first occurrence of given collection within this collection. Hmm. Available when element confronts to equatable. What to say? I'm not sure how much I like this one. Flat map. This is some string thing, so I'm form index, index offset by indices. Map is something, so yeah, let me write map algorithm. So map algorithm basically returns a collection, and similarly we have contains range algorithm, and that is something like a state search. Prefix is there, random element I would not implement, removing subranges. Oh, so this is discontiguous slice. This is something, uh I will have to see what is this one. And do we have a concept of discontiguous, a collection wrapper that provides access to elements of a collection indexed by set of indices. So this is a struct. Hmm. I do not have any intention of implementing it right now. Trimming prefix, that is fine. Let's go to bidirectional one. What are their contents? What is the difference? Returns a different order element from given collection. What is that? Collection difference produce this collection order elements from given. Wow. Returns a different need to produce this collections order element from given collection. I don't know what does that mean. Okay. Hmm. Let me see some chat if there is some. I do not know what does this mean. Distance I know. Drop last. What is first match? What is this first match algorithm? Wow, this is some regex I have. Okay. What is first match algorithm? I'm not sure. What is this first match? Hmm. I want to. Um, and then again, first range algorithm and given regex. Form index, index matches. This. Mhm. Okay. I do not want to implement this thing that searches uh, range inside other range, because that goes through some complex like KMP or some kind of algorithm. So I want to avoid it currently because usually it's not very useful for me. So what is returns a new string? Okay, new string is not something I want to focus right now. Pop last, ranges, reversed. What is reversed? Reversed is this reverse collection. This is something I can try implementing. This is something I can try implementing. Hmm. And whole match. Random access collection, I know. I'm not saying things like, okay, that could be mutable collection thing, right? Mutable collection. Yeah, here are the thing: partition by, remove subranges, sort, swap at, and all these things. Hmm. So what should I try? Hmm. I don't know what I'm interested in trying. I think reverse collection is something I have to implement the whole hierarchy of thing there. That is a thing, and yeah. Should we try this partition algorithm? Like, what is I think? Reorder elements is that all elements that match the given predicate are after all elements that do not match, and there's a pivot index where there's no element stable. So relative ordering of elements within a partition might change. Okay, so we have this partition thing, and relative ordering is not guaranteed, right? Hmm. So we might try implementing partition. I know there is some discussion of stud partition implementation in C++ community. Okay, so reorders the element and all these things, right? Complexity. Huh. So how to implement partitioning algorithm? This is what we can try. How to implement state partition, right? Uh, this should be a nice thing for rs-stl. Let me try this. So for partitioning, I think I only need reorderable collection because other things are not required at all, right? This rotate is so nice. It was so nice of an exercise. Okay, so I need self, and I need to partition by something. So by f, right? Uh, where f is a function that takes element and returns bool, partition by. And what should be the name? Like, so the one thing that I like in Swift, and that is not there in other languages, is the labels for the arguments. So if I talk about it, here is the thing. So this partition by algorithm, right? So this belongs in second partition argument has a label by, and by actually looks so good, but what we actually need to call is partition by algorithm. This is a partition by algorithm and not partition belongs in second partition algorithm, right? So the argument name is belongs in second partition, but the label is by, and these labels are can be thought as something that is a part of the name of the function. So that is the thing. I would name belongs in second partition. One thing I have a big doubt that why Swift goes in the other direction. That means this partition by algorithm in Swift uh, takes the argument, and if it belongs in the second partition, those things goes to the second partition. That means this predicate function, uh, if that returns true, then the element goes to the last, and that is exactly, I guess, different in C++ STL, if I'm right. So here is the thing that reorders the element in such a way that all elements for which predicate returns true precede all elements for which uh, predicate returns false. So that is exactly the opposite way. So I am really curious why Swift took this direction, because I know that uh, this should have gone through Dave Abrahams, so he might have some good reason for that. I want to know. I can try asking ChatGPT, but I am really unsure if ChatGPT really gives some good suggestions. But I would go in the Swift direction so that I can just use all these algorithms while writing things for high-low. So reorders the uh, collections such that element satisfying given predicate comes after uh, predicate is followed by elements which doesn't satisfy predicate. I think I can try screen key today. Yeah. Okay. So post condition, relative ordering of elements in given partition in the partitions are not preserved. So this is an unstable partition algorithm, and this is really a good way for writing a quick sort, right? Complexity, I guess this is order of count, right? Hmm. Okay, I can try writing an example for the same. So let's say we have an array like 1 2 3 4 5, and error dot partition x modulo 2 is 1. So it should be like, okay, let I is this one, and the partition algorithm should return the partition point where the second partition starts, right? So and that should be 24012, and it should be 2 comma 4 then 135. And interestingly, we cannot guarantee this thing, right? Because here we are actually assuming that relative ordering is preserved, but that is not the case. That is the precondition, that is a post condition we have, that relative ordering of elements in the partitions are not preserved. So this is unstable partitioning, and we need to think about it. Let me just ignore the error for time being. So what I can do is I can do like arr dot prefix up to I dot all satisfy, and x modulo 2 is 0, right? And I can just assert this whole thing, and the same goes for suffix from I all satisfy that it's 1. So this is something we want from partitioning, that the even come first and the odd comes last. I am not sure if this is good enough of a summary, and I think Swift should provide us a better summary, right? Reorder the element of the collection such that all elements that matches the given predicate are after all elements that do not match, such that elements satisfying the predicate are followed by elements which don't satisfy the predicate. I think there should be a return value, right? Or return value here. So, so index the first element in the reorder collection that matches belongs in second partition. In the position of first element in collection after reordering that satisfies given predicate, that satisfies, and I can just quote here, belongs belongs in second partition. Yeah, belongs in second partition, right? If no such element exists, then return self dot end. So yeah, this is something uh, good enough for method definition, and now we can try implementing it. Okay. One way is we go through the C++ way and we implement the CPP reference algorithm. Second way is I can actually try doing I can actually try doing the slice first year algorithm implementation, but let's start with the CPP reference implementation, and then we can try to upgrade that if possible, right? So let's see what is that implementation. Here there is one thing, and that is what I'm doing right now, is I am passing this function, and I want this function to be clonable because I would pass it to uh, other algorithm like first element, your first position algorithm. So that is the case, and in rs-stl I am actually passing functions with value. So if I would pass it, then it would get moved, and thus I want a clone constraint. And for the whole project, I'm assuming that the clone constraint is actually trivial. So that is the thing. Hmm. Okay, so let us try. Let's try. Let me open GIMP and let me try to understand this algorithm. Hmm. So I have, wow, that is so bad. I have some elements, and I would try to implement this one. Okay, so I would just go simply 1, 2, 3, 4, 5, 6, 7, 8. Right now, what I want is all the events uh, go to the last. Okay, so these are events, and all the odds come to the first for solving this problem. Uh, Let me try that. Nice. For solving that problem, first thing is, because all the odds that are first there, uh, they are on the right position. We do not want to actually disturb them, right? So I want to get the first position, uh, which is an even, right? So let me get that. So when I say which is an even, that actually means belongs in the second partition. So I guess I do self dot first position where, and it belongs in second partition, right? And that is another algorithm I'm using, I have developed in past. So let mm, mute, and what is this algorithm? This is what I would call a right position, right? So for time being, let me implement to do here. Okay, so this is a right position, and now I got the element. The next thing is, I'd go from here, I would go to the next element, and if that next element is something that should be in the first partition, I would do swap uh, with this element, and yeah, that would be the strategy, right? So write self dot for next right pose. Okay, and if right position is self dot end, we need to think. Uh, so if there is no element that belongs in second partition, then we just return end. That is as simple. Now we start uh, that. Uh, hmm, okay, nice. What do we want? Hmm. So uh, self dot form next. Okay, I have this right position, and where I can actually write, and this has the element of the second partition. So what I can do is self dot suffix. Yeah, I can just use suffix uh, from right position. Let mute rest. So let me create a slice. Okay, while res dot pop first with position, and what I can do is while let wow some of I and E is this thing. Okay, so while I pop the element and I get the element, if and that should be the clone, if belongs in second partition, wow, there are so many things, like this should be mute. Okay, if belongs in second partition, and now if the given element does not belong to the second partition, that means that element should be in the first partition, and now I should swap that element with the right element. Got it? So hmm, self dot swap at right position and I, and next thing would be right pause for next, and this way we can do the things, right? And for the loop invariant, I can say one thing for sure, that this right position is actually the position where elements of second partition is always there, right? So I can just return right position, and that should be good enough for the algorithm. Hmm. Now let's see. Wow, I have to get a habitual. Okay, found element ref. Okay, E is element ref, so I can do this thing. Self dot swap at. Wow, now hmm. Okay, because I can do result dot swap at, but again, oh, result is a slice suffix from mute. Can borrow result as mutable. Okay, this is so hard to write in the slice form. Hmm. Okay, that's fine. While let I is self dot next of right pos dot clone or self dot problem. This is fine. This is totally fine. While I is not equal to self dot end uh, if not belongs in second partition, self dot at I and this, so self dot swap at right pos and I and self dot form next right pos. This is exactly the same implementation. Hmm. And after this, self dot form next. Well, I wanted to do this in the slice first year way. I did not want to do this manual iteration, to be honest. But yeah, let me first try this out if this thing works. Hmm. What do you guys think? It will work? I think it would. This thing totally makes sense, and this works. Nice. So I can try writing some tests for the same partition test. Do we have partition test? What is this partition point? Okay, as test fn partition when both parts are not empty, right? And I can just use the same example here. Y forsake, right? And let me try this one. This works. Partition when both parts, partition when first part is empty. That means for us, what should be the case? That means there is no 2 and 4 here, right? And then it should be 0, and it works, right? Partition when second part is empty, and that should be, let's say we have 2 4 6, then it returns 3 and 0 1 2 3. It should work, right? And we do a cargo test, and that should work fine. Hmm. This all makes sense now, right? So yeah, now let me think about this one as if we can do something better, right? Okay. Hmm. So I think this is the same this algorithm did. This is the exactly the same thing this algorithm did. I want to see if I can do better. Well, I think it no very nice way of implementing this. A very nice way of implementing it would be using slice first design. I think that would be really nice to see how we implement the whole thing with slice first design. Hmm. But yeah, this is the current implementation of the partition algorithm. I need to think if I can do it in a slice first year way. So I think for implementing partition, we need some kind of trisection, some kind of trisection, right? Okay. But hmm, so here, what I hate is I do not want to work with positions like this form next and all these things. I hate it, to be honest. Hmm. I am thinking. So, what is the way? Like, I see there is one part, and this part actually contains the odd elements, right? And there is one part that actually contains even elements. Now, there is also one part that contains remaining element. If this is something I have to think about, and for the remaining element, right? We think about the first element, and if this first element is okay, we compare the first element with the first element of uh okay, if this first elements should be in the second partition, okay, then that's not a problem. We just grow this one and that's it, right? This is how it goes. But if this is not the case, then this element should go in the first partition, and then what we do is we swap both of it, we grow this one and we grow this one, and this way we, oh wow, this is so nice of an algorithm, like this partition algorithm is so nice. Okay, I really like this partition algorithm. Wow. Wow, this is so nice way of thinking the whole thing. This way is so structured, this way is so structured than the above way. With the above way you do not even know what is actually happening, and this way brings structure to the algorithm, because this way we actually add meaning to the different the different regions, right? That part 0 is actually the one that should be in the first partition, part 1 is something that should be in the second partition, and remaining is something that should be in the that partition, right? Nice. Hmm. And I think I should. Hmm. I do not know the semantics of the find algorithm there. Like the find algorithm, what does that do? uh, so with partition with first element dot partition with first element with first. Wow. Ah, I really want them to return like collection partitions. uh, yeah, I really want them to return collection partitions. It's an easy one. Like, should I try doing the positionless one? Split split first. What should the name? Like, okay, I can ask ChatGPT for the good name, right? So ChatGPT can help me. Like, why is it there? It should not be useless. Hmm. So here is the thing. You are there to help me with some positionless design n- algorithm naming. Are you excited? Now, here is my um, here is my thinking. You know, instead find if right. Similarly, we have first index where algorithm. Similarly, in rs-stl, I have implemented first position where algorithm. Now, this where algorithm is really this is really nice, but we need to think about positionless design. All of these algorithms are returning positions, and that does not fit my the design at all. Now here is my thinking. If I call, let's say, similar algorithm named f on collection, it should return me partitioning, and that partitioning is a bisection. First part of that bisection should contain elements before uh, the first element predicate satisfies, and second part should contain elements containing first element predicate satisfied and the rest. Did you get my point? So I am thinking of a good name for the same. Oh, I see. Where are you going? This is exactly the kind of place where the positionless model shines. Instead of exposing a cursor position You just cut the collection at the right point and let the partition represent. So returns, but no model returns bisection at the first match. That's a beautiful abstraction. Now let's think about the names. Avoid position because we have thrown that away. Emphasizing partitioning and splitting action, keep parallel with existing around like find if and candidate bisect, split bisect where partition first where. But I think bisect where is a nice name, right? Bisect where is something I can use for the positionless design. This algorithm, so that should be a substitute for stat find if for our implementation. I would go with bisect where. And actually, this is a very nice example. This, if I implement this partition algorithm for positionless design, I can actually do a great thing in Halo meeting, and I can actually say against we should have two kind of partitioning and two kind of slices. So I can say against that fact because I am feeling that would add a lot of complexity to positionless design. So let me implement that. Yeah, but this one is nice. I have to think if we can do it in a more slice first year way, but this implementation just works like right. This looks so nice. Okay, so now time to Swift from Rust to Swift, positionless Swift. Oh, what did I actually implement it like git diff? Oh yeah, this was my thinking. That was my yesterday work. Anyways, git pull origin slice impl. Yeah, I have nothing to do with. I have. Wow, what is this? Git status. Anyways, hmm. Okay. Git checkout minus b impl partition algorithm. Hmm. Let me turn on the screen key now because this is looking awesome to me. This plugin is awesome. Okay. So algorithms, and let me go for the single pass algorithm. This is not single pass algorithm. This is something different, right? Mm, but what is this algorithm? Like search algorithm or something? Okay. So search.swift, searching.swift, right? This is how I call it. I think there is a name for these kind of algorithm in ST C++ algorithms. If I search it in the algorithms library, they have a specific name for this. These kind of algorithms. I guess they call it find algorithms or something. But yeah, we can follow similar names. Patch operation, search operation. This is what they call. They call it search operation. So we'd go for searching.swift. Nice. So extension collection. I don't know why. Okay. Single pass, right? Hmm. And func bisect. Okay. Bisect. Okay. I don't know. Bisect first. Bisect where predicate takes element and returns a bool, right? And with the bisection uh, callback, and this callback takes what is this thing, parts. Wow, this is the return value, and it takes parts and return r, in out parts and return r. Does that make sense? I guess this is very similar to what collection had with parts algorithm. So uh, bisect where, and then we have uh, we call f with those parts, and that part is bisection. And why we are doing this currently, we are not returning a projection, is we do not have a syntax where we can project an mutable thing out of an immutable value. So that thing is in a research topic for high level programming language, and we are doing it in Swift for POC, right? So bisects the collection on the first, such that uh, first uh, such that um, elements and including first element that satisfies predicate are in second part bisection, and rest are in first part of bisection, are in part 1, rest elements are in part 0. Okay, so this thing looks nice. Now what I can do is, I know there is this thing for each where, but what I need to do is with parts. Wow, this is so different. I think what I need is with mutable parts, with mutable parts, and we need two. Okay, and I would do the same way we did for each algorithm. For each, where is for each? We do not have for each. Single pass for each, like this way, with mutable parts, count to pin, and what we need to do is where parts is this thing, and we return f of parts. Wow, what's the problem? Expect a non void return value. Okay, and this whole thing returns r. Anyways, uh, so with mutable parts and p in, now let's start implementing the whole thing. Hmm. While, oh my goodness, wait a minute. I don't know. bisect. Currently, I'm writing bisect mute. I'm currently writing bisect mute. I do not know. This mutability thing is annoying me right now. While part one dot is empty, so the second part is not empty. If we call the predicate with part one dot first, and if predicate satisfies, we basically break, right? Type of okay, this is problematic. Well, okay, with mutable parts. Hmm. And we when and then we do f of p. This is what happens. Wow. Type of expression is ambiguous without a type annotation. Why is this ambiguous? With middle parts, this thing p in uh, p dot grow part 0. I'm not getting why with parts. Let me go with parts. Hmm. With parts count 2 p in. I think I did exactly the same thing, right? Hmm. In out parts, what's the problem? Let me compile it. Swift test. Hmm. If predicate with parts, type of expression is ambiguous. Nice. Predicate p part 0, that was a problem, and return f of p into, and that should be the case. Yeah. So now this is the bisect mute algorithm, and I really want it to be with mutable parts. What's the problem? uh, Self is immutable. That's a mediating function, right? So I think, hmm, so I would go with the bisect thing, and let me just do, the basic thing. So we have with parts. Now what happens with this kind of method is we are bisecting the collection into two parts, right? If I say, give an example, I have, let's say, 1 2 1 3 5 4 7 8, and so the bisection point, if I pass it a predicate that returns an, if element is even, then it's true, then it should be like 135 and 4 7 8. That's the bisection. And because we do not have concept of positions, what we can do is we can only return these kind of bisection that does not lose the context, right? Now this bisection, what kind of property this bisection has is a important thing. So now this bisection has like what is this bisection? Bisection returns a part, that is the partitioning. Now this partitioning can be mutable and can be immutable. And when the partitioning is immutable, that means you can still change the partitioning. Okay, you can still change the partitioning, but you can only change boundaries around it. You cannot reorder the element or change the element. So that is the thing. So with part method actually calls this bisection with that property, that immutable element property, right? Permutation is immutable as well as the elements are immutable. However, if I think about the case, then where you can also have mutability, right? Because I wanted to use this algorithm for partition, right? I want to use this algorithm for partition uh, algorithm, and this partition algorithm actually requires mutability, and the partition algorithm actually requires mutability, and that is a thing. And now we do not need this mutating. We do not need this mutating, but I would have two algorithms. One would be bisect, and another thing would be bisect mute. And then there comes this thing that from a mutable partition, should I be able to project an immutable partition? Right? This is so complex. What I would do is adjust, you know, complexity order of count, right? I just do this complexity order of count, and we can just move it uh, so that we can actually create extension mutable collection, and I can just give this whole thing to Dave Abrahams to discuss in the next Hilo meeting, because I think this should be discussed with mutable parts, and that is a mutating thing. So for every function like this simple function, this is uh, bisect first. I am not liking this name. What is this name? What was that name? Split first where, split first where, and split first where mute. I was not liking the function name at all. Bisect. Anyways, bisect the collection such that elements after and including first element that satisfy. I am not lacking the summary. Can you give me better summary? Assume I am using split first where name. My grammar is so bad. I have to work on that. Got it. Split the collection, the first collection, the first element that satisfies the given predicate. And I can just put this thing in post condition. Part 0 contain all elements before the first match, and part 1 contain the first matching element and all elements after it. This seems so nice. I have to learn a good amount of grammar, right? Hmm. This is good enough for a PR, and I think this would be a really good point of discussion. Split first where. Okay, we can just put it like implement partition algorithm. Should I try implementing the partition algorithm? That is actually fun. That is actually fun. So partition.swift extension mutable collection func. Oh, but I think I would not implement it because it is not making sense right now. I have a bigger problem to tackle because the problem is the explosion of algorithms with this design. We should not have these two variants. Otherwise, any searching algorithm would explode. Any searching algorithm would explode. And you can think of why I'm saying explosion is you can use that algorithm and then you create partitioning. You use that algorithm for composition, and now every point of that composition you have the choice that this thing should be mutable or should be immutable, because we do not know what user wants. So that is bad. Hmm. I would just change the branch name, git checkout minus b impl search impl find if. Implement. Let me first try at least Swift test so that I can be sure it compiles. Otherwise, that would be really bad from my side. Yeah, it compiles at least. Implement find if algorithm variant find if algorithm for positionless design. Git push origin. Hmm. Now I can start discussing this thing with Dave. I don't know if there's something going on Slack or something I'm missing. Let me try. Let me check. I don't think there's anything going on. Right. Dave is online, but there's nothing going on. Okay, fine. Might be busy with something else. Yeah. Anyways. So high low lang slash positionless Swift. Hmm. Pull request. And I have already two pull requests that is pending, and all of this is actually stacking up because we are unable to conclude on mutability part, and I think we have to do a serious meeting on mutability part. uh, it should not have been like, yeah Risha, what's the problem? It should not have been like that. There is a problem. There is a problem, and I think we have to do some serious discussions now, because otherwise uh, WIP implement positionless implement positionless Instead, find diff alternative. Hmm. So, why I want a serious discussion on this in tomorrow's meeting is, if we would not have serious discussion, uh, we would not be able to complete the whole thing before advent of code. And I want to make this project to a good part before advent of code. As before advent of code, if it uh, I actually want to try this whole thing in advent of code, that is this whole concept actually working, and can I actually do some real things with this algorithm library and with this algorithm design at all. So that is the plan. uh, so as positions are not a thing, I believe we need to create a bisection as an alternative to state find if algorithm, right? uh, where first part could contain elements before the first element that satisfies predicate satisfies the predicate, and rest would be in second part. uh, however I want to however despite this being a simple algorithm, I have a separate here, as I need to discuss implication of having multiple partitioning as a thing in our design, right? So in the code we can see I needed to implement two algorithms. What were those algorithm names? Mm, oh wow, split first mute, and it should be split first. Otherwise, Dave Abrahams would just give me the Swift API guidelines to read. Okay. Okay. Mm, rename to better names. Okay. Okay. Yeah. That was a big thing. And I do not want mute here. The reason for the same is as an end user perspective, I might want to use resultant partitioning for multiple for non-mutating algorithms like search or mutating algorithms like a reordering one. Now, my motive was to implement stir partition algorithm for, but I think this is something bothering me. This algorithm actually means if we any algorithm needs to project partitioning, it should have two variants of it. First one with immutable partitioning and other one as mutable partitioning. To explosion of future. So now my motive was to implement partition algorithm and I needed slice. But I think there's something bothering me. This algorithm actually means if an algorithm needs to project a partitioning, it should have two variants of it. First one with immutable partitioning and other one as mutable partitioning. This will lead to explosion of algorithms in future. Mm. Okay, as positions are not a thing, I believe we need to create. Uh, to instead find if algorithm where first part would contain I will need to create a voice section project by section as an alternative to should find if the first part would contain elements before where the first part would contain elements before the first element. Despite this being a simple algorithm, I have found it as a need application of immediate partitioning design. In the code, how we see need to inventory glass split first transfer first make clear the reason for this is I might want to use filter partition for normative question like searching or making like water. Now my motive was to influence partition and it split. I think this is something both about actually. Massive and information better in algorithmic data partitioning. We should have two variants of it. First one with immutable. The similar is there in rs-stl, but there for the just return and can and choose if reported on side to as caller might want to might or might not want to imitate the base collection using projected partitioning. Now my motive. My motive was to implement strip partition for the and I needed that time with something bottom as as if any node needs to project a partition, it should provide to separate. First one with the immediate partition and other one is middle partition. This should lead to explosion importance in the future. This Nice. Yeah, I think I'm quite happy with the progress today. I did not expect that uh, this split first thing itself would be a problem. Hmm. So I think I did a quite lot of work, right? I think I did a lot of work. Hmm. So for rs-stl we implemented the partition algorithm, and with the partition algorithm we came to implement this thing, and we failed in the position design because we have these two variants. Now Dave might ask how many algorithms are there, but then Hmm. So what's next? I think I'm quite done with the day. I would see if I want to do something more, uh, but I think what is the next? I want to read some. I want to do some GitHub scrolling, so I would continue that. ST lab/better code, right? And how many conversation we have? We have 210 conversations by Dave Abrahams, and there are so many reviewers, and I am going to read each and every uh, review of that, right? So let me start. Mm, Maybe with a different word. I would go with each and every review. There are many things I have done. I want to read the exchanges from between Dave and David Senkel, right? So that I can get a little bit of idea like how uh, legends like Dave and David Senkel actually talk, right? So context tells us which code. Oh, this one is so nice. If anyone is going to watch this thing, they need to know this one uh, is so nice of a conversation. So let me give you the context. The context is what Dave Abrahams claim that when something goes wrong in software, focusing on which person to blame is counterproductive, but deciding which code is to blame is the first step, and contracts tell us which code needs fixing. Now, what David Senkel said is, I once believed this but have since realized it is a logical fallacy. And that is a nice thing, right? Fallacy, I think, is something that is always true or always false. So a false belief, that is a false belief. Okay, it's a logical fallacy. It's a logically false belief. The contract, like the code itself, can be defective. The most you can say is there is a contradiction between the contract and either the implementation or the caller. And he is true here. He is true, right? He's saying the correct things. I want to know how Dave actually uh, react to it, right? Contracts allow you to identify the presence of bug, but not where. And yeah, what Dave said is there is no fallacy at all. If there is a contradiction between the contract and the implementation, the callee has a bug. Okay, the caller has a bug or the callee has a bug. Oh, wow, he's so nice. He's so precise of a person. Uh, okay. uh, okay, that is so nice. There is no policy at all. Wow, Dave is actually a legend. Dave is a legend, man. This guy wrote a single line and it makes sense, right? That either contract is wrong or the code is wrong, update it. So, if there's a contradiction between the contract and the implementation, the callee has a bug. The maintainer of the callee has two choices then: update the implementation to match the contract, update the contract, and maybe updating the implementation to up auditing or updating all the clients. In general, though, option 2 is not available, and the best you can do is hope client forwards the contracts. So everything become consistent when you take option 1. In any case, uh, that is the only choice that scales, and responsibility falls entirely on the maintainer of the callee to address the problem. Crystal clear. Wow, I do not know why are there no person on the stream. I do not know. I do not know. And uh yeah, I have to say people are what to say. I am really disappointed with the people. Uh, like they are not here and they are not watching this pure cinema. Like this, there's so much to learn. And wow, there is no one here. Wow, that's nice. Okay, please either resolve the conversation or add something. Thanks. That is the classic Dave Abrahams. Okay, your argument rests on the premise that contract is infallible source of truth. In practice, the contract is a human artifact just as prone to bug as the code itself. Consider a common scenario where all code is initially correct. A developer rewrites function contract for clarity but unintentionally alters its meaning. The implementation and all its color remains unchanged. Later, another developer sees the discrepancy. Following the principle that contract is law, they update the implementation to match the new faulty contract. Change breaks every color of the function, causing production issues. And these are the correct things. Like this is also not wrong, right? This is a legendary thing. This is a legendary thing. Like the guy is crystal clear. I love this argument, and I do not know people. What are people doing? What are they doing? Why are no one there in the stream? Why am I streaming this thing when they are not actually seeing this legendary thing at all? Wow. Anyways, in the practice, the contract is just after step two, the implementation perfectly matches the contract. By your logic, the bug must reside in every single of its callers. However, common sense tells the problem was introduced by faulty contract change. Step 1 and propagated by misguided fix to implementation. Step 2, the true solution is to fix both the implementation and the contract back to their original correct state. This demonstrates my original point. A mismatch only tells you there is a problem, not where the bug is. It's a great argument, and I love the argument. Let's see how Dave responds. No, it does not. Oh my goodness. Here is the classic Dave Abrahams. The classy. He is the classy. He's a legend. Okay. Come on. Why is there no one on the stream? Whoa. what to say. What to say. Should I do a reaction video now? Should I do the reaction video and yeah. I'd stop this one. I would stop this live stream and I would start another live stream, and that live stream would be regarding this one. Okay, and let's see. If people come, there is a lot of thing to actually learn, right? And if that would not be the case, if people do not come, then yeah, I am really disappointed with what people are doing. Like, whoa, it's so bad of where the programming is heading towards. uh okay, I'm stopping it. Okay, and